Honorable Chief Guest, Professor R.K. Khandal, Guest of Honor, Mr. R.K. Bhatnagar, Mr. N.K. Goyal, Keynote Speaker, Mr. R.K. Upadhyay, all expert speakers, chairpersons of various technical sessions, participants of this seminar, distinguished guests, members of the press and media, faculty, staff, and students of IPEM. Especially, I welcome Mr. M.C. Verma, my friend, my class fellow, and as a member or chairman of our advisory body of management, who is present. Thank you. It gives me great pleasure to extend to you all a warm welcome on behalf of IPEM group of institutions, and to express my deep sense of gratitude to the distinguished guests and participants who have accepted our invitation to convene this seminar on the topic Next Generation Information Technology, Innovation and Challenges in National Development. We are delighted to have Professor Dr. R.K. Khandal, Honorable Vice Chancellor, Uttar Pradesh Technical University, UP. Earlier, we had the privilege to welcome Professor T.S. Chauhan, Founder Vice Chancellor of UPTU in the year 2004. It was Dr. Chauhan who inaugurated this Lakshmi Chand Auditorium in the year 2004. Professor Dr. S.K. Kak, Honorable Vice Chancellor of Ramaya Technical University, was also the Chief Guest of National Seminar in the year 2012. So we have the privilege of welcoming our Honorable Vice Chancellors of UPTU, to whom we are affiliated to this institute here, now and then whenever there is an opportunity. Professor Khandal is known for his virtues as a teacher, mentor, manager, leader, and orator and innovator. He not only professes the values of Indian culture, but also practices many of the fundamental principles of humanity and society while dedicating himself to the cause of technical education, managing science and advanced research. I can just refer a recent experience with him. When we were coming on the staircase to light the lamp, he told that we should come from here, we should be clockwise. That is what he told. And when we were there, I think that we again say that the lightning should be clockwise on the lamp, not anti-clockwise. So he is very conscious about the Indian culture. That is just a indication how much he follows this. We are really fortunate to welcome him and to be what he suggested. Professor Khandal's presence and participation in the activities of IPEM will always be a source of great inspiration and motivation for us. I welcome Professor R.K. Khandal as the chief guest in today's session. Our guest of honor today, Mr. R.K. Bhatnagar, former advisor, Department of Telecommunication, Government of India, is a renowned IT professional. Mr. Bhatnagar has been actively associated as an ITU telecom expert for a number of national and international projects. I welcome Mr. R.K. Bhatnagar as a guest of honor in today's seminar. Our distinguished guest, Mr. N.K. Goyal, is a result-driven senior professional with varied experience. Being in the field for 42 years, Mr. Goyal is known as a telecom father figure in India. Mr. Goyal is perhaps the only person in the world inaugurating and ribbon-cutting world's largest consumer electronics show, CES, Las Vegas, USA, for continuously 5 years. He we are fortunate to have such a distinguished person amidst us this morning. I welcome Mr. Goel as the guest of honor in today's seminar. Thank you, sir. I am grateful to our keynote speaker, Mr. R.K. Upadhyay, former CMD BSNL, New Delhi, who accepted our invitation and spared some of his valuable time for us. We are fortunate to have such a distinguished person amidst us this morning. Thank you, sir. In course of his service, Mr. Upadhyay gained valuable and diverse experience in the areas of planning, installation, and commissioning, commercial administration, and operation. He has handled important foreign assignments at Ghana, Yemen, and Algeria while working in TCIF. I welcome Mr. Upadhyay as the keynote speaker in today's seminar.
Goes for a meeting, next year another person goes, there is no continuity, and in that process, as for the international standardization process is concerned, we have no presence. We have big companies like Wipro. As far as ITU is concerned, ITU can have the participation of the private sector also. ITU can have the participation of the institutions also. At present, there are certain institutions in Bangalore, 2 institutions in Bangalore, which have taken up the membership of ITU. So, universities in UP also can take note of that, because this is we are having the MCA, BCA, BTech courses in computer, PhD programs also are going on. So for the institutions it is very important. Now you have to select a topic for PhD. Now you see whatever comes out in the books which are finalized, the books are containing the information which was possibly finalized at the international level maybe in year 2008, 2009. But if the students are familiar with what actually is going to happen, what standard is going to be finalized in 2016, so they are well ahead of everyone. They can be a sort of a, so PhD or that kind of work, if they do these type of areas in which the activity is an ongoing activity, the standards are in the process of being finalized, some standard may be associated where there is innovative and initial work done by them in a company in India, or a university in India, or at any organization in India. So this is an area, because I found that today many students are there, so that's why purposefully I thought I should try to bring the subject before you. If any support is required, I am available to provide assistance to the universities in whether it is UP or anyone else. I have already retired from the government service in 2013. Now I am available. I can provide the support, so that now you see it is ICT is an area in India which is, in terms of the revenues, if you try to see, India is generating maximum revenue from the exports of software and related activities. But the potential can increase manifold if we are involved right at the stage of the finalization of the standards. Now you can see that some of the various set of the collective letters, various set of the reports, various set of the standards, etc. They are there. Now you can see that as far as today's workshop is also concerned, access network transport standardization overview, that is in the process of being finalized. Cloud computing, big data and its use for flight data. So this activity is in the process of finalization. Then the progress of technical report of counterweight ICT equipments, signaling requirements. So like that, you see this is some of the already from 2013, on the left column you find the number. So already more than 300 contributions have already been received from the various countries. When 300 contributions have been received, if you try to see that who are the countries who forward sent across these inputs, you will find that 50 to 60 will be from China. From small countries, as I showed to you, Burkina Faso and like that, very small countries, they have also sent their contributions. But I don't find any contributions from India, including the big names of India, Infosys, Wipro, etc. So they are also not there in the contributions which have been sent across. And it is in the area of data, computer architecture, I'll show you one of the recommendations also, recommendations which get finalized, so that you have a feel of that. So there are various working parties are also there, because as far as the particular subject is concerned, so things are being decided by the various working parties. So like in colleges also we have the various expert groups, the various faculties are there. So the professors in charge of having the particular expertise, they can have a different set of the team. In the same way, for the study group, which is addressing these issues relating to the future networks.
सर थोड़ा सा यूपीटी के लिए बताइए क्या कर सकते हैं हम लोग इसमें और हमारे बच्चे क्या कर सकते हैं.
Sir, as far as the students are concerned, first of all, as far as the technical universities are concerned, we can take the institutional membership of IPEM. So that is possible already. Some while I was advisor technology during my period, two colleges from Karnataka, so they have come forward with the DOT. So DOT can sponsor their application, and at the IPEM level we can get them up. So you can get the membership, and the type of documents which are there, they are not available in the public domain. I will just try to show you some of the documents, because today you are in a very detail, you are going to see the various topics. On those topics, whatever is being taught to you is on the basis of whatever was finalized, say in year 2007, 2008. But now what is going to be finalized in 2016 is also available with us. So we can take note of that, because many of these recommendations, they have reached 95% level of the finalization. Some are there at the middle stage. So depending on if there is a participation from the colleges, they can take up the membership of the ITU. The institutional membership is possible. In fact, fee waiver is also possible. Fee waiver as an institution, I think I have given my card also. In part-time capacity, I am representing ITU EPT Foundation of India.
Oh, very good. Thank you. Give a big hand to it.
No contribution, no money. This organization also, ITU EPT Foundation of India, we have not given any money to ITU. It is an honorary capacity without making the payment. We are the member, and we are the member for more than a decade. Mr. Goyal is also one of the officers here of ITU EPT Foundation of India. So our institutions can take a membership, and then we can have access to the latest set of the documents. As for the PhD students are concerned, for example, they can select some of the topics and do the PhD thesis on them, and then whatever is going to be finalized, because PhD has to be there on something new, something innovative. So you will get many new innovative ideas from the IT study groups. So I think my time was there for a short duration, but there's not a problem. At a later stage, as far as I can come across a second time, so that I can go into more details on the topics which were of interest, because there are other speakers also. But before I wind up, I would definitely like to mention about maybe show you one or two sample cases of the recommendations. One of the standard which is in the process of being finalized, ITU Y3502. This is giving the global information infrastructure, internet protocol aspects, and next generation networks. So this is being addressed in this side of the recommendations. But this is not the only recommendation. You see, there are series of recommendations are there which are addressing the different aspects of the telecom and ICT networks. So I just you see, at functional level, as for the standards are being finalized, at each and every stage, you are having, say for example, in this particular recommendation, how the standards are actually getting evolved. So the full stage by stage description of that is available. Because when something gets is finalized, you only get the end product. What is that? This is the end product which is finalized. But here you go through each and every stage of the process as it is getting finalized, and as to the this is clouds serving customer, cloud service provider, cloud service partner, rules and sub rules. So this particular.
And that is why they are being given new technology. हमेशा कहा जाएगा, कोई गारंटी नहीं देगा कि 3G में स्पीड क्या है, 4G में स्पीड क्या है, बेटर स्पीड, बेटर टर्म्स, व्हाट बेटर, व्हाई बेटर, क्यों नहीं गारंटी दे सकते? और आई एम श्योर आप लोगों ने इंटरनेट पे देखा होगा कि किसी ने टेस्ट किया था कि एक उसने कबूतर के जरिए कुछ डाटा भेजा, वो पहले पहुंच गया नेट के पहले. आई एम श्योर यू नो दिस थिंग. आई एम श्योर यू आल्सो वुड हैव सीन द इंफॉर्मेशन ऑन द नेट कि जो इलेक्शंस का सीटीओ हेड था उसने कहा था हम जो प्रॉमिस कर रहे हैं दे नहीं सकते. उस वजह से हम लोग हमेशा टेक्नोलॉजी बातें करते रहते हैं. बड़ा इंटरेस्टिंग है. अभी हम 3G की बातें कर रहे हैं. देयर आर हार्डली 5% कस्टमर्स ऑफ 3G इन इंडिया. मोस्ट ऑफ द पर्सन सिटिंग हियर यूजिंग ए 3G स्मार्टफोन वर्किंग ऑन 2G. वर्ल्ड में आज तक कोई ऑपरेटर 3G का प्रॉफिटेबल नहीं हुआ है और हम आज 4G की बात कर रहे हैं. आप सब जानते हैं, गौरव में पढ़ा है कि रिलायंस के पास लाइसेंस 4G का था, आज 2 साल से सर्विस शुरू नहीं हुई है. तो टेक्नोलॉजी चलती रहेगी. बच्चों के लिए क्या है, आप जब पढ़ रहे हो तो आगे का भी ख्याल रखो. आपसे पूछा जाएगा इंटरव्यूज में, कैरियर में. और हम लोगों के लिए सिर्फ ये है कि टेक्नोलॉजी आती रहेगी, बढ़ती रहेगी. इसके बाद नेक्स्ट में कहना चाह रहा था कि इसको बोलते हैं कनेक्टेड वर्ल्ड. इस तरह से चीजें बढ़ रही हैं कि आने वाले दिनों में ये कहा जाता है कि 10 सालों में करीब 50 बिलियन कनेक्टेड चीजें होंगी. जो आप सोच सकते हैं, जूता है कि गाड़ी है कि फ्रिज है कि गाड़ी है कि बिल्डिंग है कि कैमरा है, हर चीज इंटरनेट से कनेक्टेड है. आई जस्ट वांट टू आस्क यंग स्टूडेंट्स, आप लोग इतने बड़े IPM कॉलेज में पढ़ते हैं, क्या आप गेस कर सकते हैं कि एक हवाई जहाज के अंदर कितने सेंसर लगे हो सकते हैं? एनीबॉडी गेस? अगर कोई गैस के 5% 10% आगे पीछे रहा, उसको एक टैबलेट फ्री इमीडिएटली ऑन द स्पॉट. एक जहाज में कितने सेंसर्स हो सकते हैं? कुछ तो गैस करो भाई. IPM के बच्चे हो, डॉक्टर गोयल के साथ हो. क्या बोला? आवाज नहीं आई? प्लीज एनीबॉडी? वेरी बैड, वेरी बैड. सो कुछ तो बताना चाहिए. अरे कुछ गैस ही कर लो, गलत होगा तो क्या होगा? और बढ़ो, आगे बढ़ो. चलिए मैं बताता हूं आपको. 7 प्लीज 7 क्या? 7 सेंसर्स. ओके, सिट डाउन. थैंक यू. कुछ तो देखिए, सुनिए. अभी खंडर साहब आपसे बात करेंगे, वो बताएंगे आपको. जवाब देने में घबराओ नहीं. गलत है तो क्या हुआ? सबसे गलती हुई है. आज वो टॉपिक नहीं है, बट हमारे पास एक प्रेजेंटेशन है कि दुनिया में कितने लोगों ने गलती करके आगे बढ़े हैं. आपके पास एग्जाम्पल्स हैं, अब्राहम लिंकन की है, स्टीव जॉब के. सब कहां से आए हैं? अब बिल गेट्स क्या था? स्कूल ड्रॉप आउट था. अब्राहम लिंकन 21 बार फेल हुए पहले. तो घबराना नहीं चाहिए. बट एनीवे, टॉपिक ये है कि एक हवाई जहाज में 7.5 लाख सेंसर्स लगे होते हैं. 7.5 लाख सेंसर्स. अभी हम अमेरिका में थे जनवरी में, तो वहां एक अनमैन्ड कार को दिखाया गया जो करीबन 250 किलोमीटर से बिना ड्राइवर के आई थी. कार तो खैर कोई बड़ी बात नहीं है, बट इंटरेस्टिंग चीज क्या बता रहा हूँ, जिसको बोलते हैं कनेक्टेड वर्ल्ड से कह रहा हूँ. उस कार में सेंसर्स लगे थे और उस सेंसर्स की वजह से वो कार अपने आप चल के आ रही थी. भीड़ हो, ट्रैफिक हो, लाल बत्ती हो, हरी बत्ती हो, गाय हो, भैंस हो, आदमी हो, लेफ्ट राइट जहां भी जाना कर रही थी. बट इंटरेस्टिंग चीज बता रहा हूँ कि उसमें इतने सेंसर्स लगे थे, उससे कितना डाटा कलेक्ट कर रहा था. अभी आपसे पूछूंगा नहीं, क्योंकि आप कैश करना चाहो तो करो. यहाँ भी टैबलेट फ्री मिलेगी, इमीडिएट ऑन द स्पॉट 1 टैबलेट के. 1 घंटे में कितना डाटा कार कलेक्ट कर रही थी? एनी गैस? वाइल्ड गैस करो. और छोड़ते हैं 27 GB, 27 GB ऑफ डाटा पर आवर दैट कार इज कलेक्टिंग. लेफ्ट क्या है, राइट क्या है, सामने क्या है, पीछे क्या है, स्पीड क्या है, टायर प्रेशर क्या है, सब कुछ कलेक्ट कर रही थी. ये हमारे पास आ रहा है आने वाले दिनों में. उसकी वजह से नई नई टेक्नोलॉजी आ गई है, उसकी वजह से आप लोगों के लिए स्कोप्स है। आप लोग डाटा में देखेंगे, आपके टॉपिक डाटा माइनिंग है, बड़ा स्कोप है डाटा का, डाटा एनालिटिक्स का वो स्कोप है, हम आगे बढ़ रहे हैं। मेरा लास्ट एक था कहने के लिए कि जो हमारे डिलीवरी मैकेनिज्म है, अभी अगर हमें एक सवाल किसी को देना है तो क्या क्या उपाय होते हैं देने के लिए, बताइए। अगर आपको एक गिफ्ट भेजना है अपने गोयल साहब के घर पर, कैसे भेजेंगे? कोरियर से या पोस्ट ऑफिस, यही दो तरकीब जानते हैं हम लोग। बट जो आज का टॉपिक है टेक्नोलॉजी क्या आने वाली है, रिवोल्यूशन चेंज हो रहा है। आपने किसी ने बात पढ़ा कल परसों की ड्रोन को परमिशन मिल गई है यूएसए में कि वो पिज्जा दे सकता है ड्रोन से, कितना ने पढ़ा? तो आपने क्यों नहीं बोला कि ड्रोन से हम भेज सकते हैं इनके घर गिफ्ट गोयल साहब के घर? That's a new technology. Drone can be used for giving pizza and anything to anybody. आप में से किसी को पता है कि ड्रोन्स इंडिया में बनते हैं? हाँ, तो इंडिया में ड्रोन्स यूज हुए थे पिछले दिनों उसके लिए। तो अभी डिलीवरी मैकेनिज्म में ड्रोन्स, अनमैन्ड कार। थर्ड टॉपिक, लास्ट टॉपिक मेरा है, वो होता है 3D प्रिंटिंग। 3D प्रिंटिंग के हम कैसे यूज कर सकते हैं इनके घर गिफ्ट भेजने के लिए? एनी आइडिया? इनके लिए खूब तालियां होनी चाहिए। आमतौर से हम लोग जब बात करते हैं प्रिंटर की तो हमको लगता है कि प्रिंटर है और उसे रखा है पेपर प्रिंट करेगा, ऐसा नहीं है। अभी अमेरिका ने करके दिखाया, उनके सैटेलाइट में प्रॉब्लम आ गई थी, यहाँ से 3D का डिजाइन भेजा बिना आदमी के सैटेलाइट में, उसने 3D प्रिंटर से एक कंपोनेंट बनाया, सिलिका आयरन जेल सब मिला के ड्रोन ने फिट कर दिया, वो काम करना शुरू कर दिया।
Sensor is required. What does a sensor do? How the control systems work? What are the logics? It is very easy. He very rightly said that we have a car which is unmanned. Okay, it's a car which is run on sensors, which is run on programs of computers and complete IT technology. Yes, of course. But somebody has to envisage that. Somebody has to prepare algorithm. Professor Bhattagar ne bataya when he went to China, Vietnam, he made a presentation. 23 countries, students had come, or maybe faculty had come, or young scientists had come. And when he started presenting his program, he found that the program is not workable because he designed it based on Indian system. And then he made groups and came out with a program which worked for so many. What did you learn from this? How to do things. You have to be very, very well prepared, my dear friends. India today is advancing, but the potential is so much that whatever we have advanced and the level at which we have reached is minuscule comparison to the level that we are supposed to be working at. Organizations like IPEM, organizations like UPTU are the big assets, big virtues of states like UP, and for societies from where you come, you must take advantage of these things. So,
in the big data. So that is how we are able to cope up with the analytics of big data. Big data analytics is often associated with cloud computing because the analysis of large data sets in real time requires a platform like Apache Hadoop, which is, as you know, Apache Hadoop is a set of algorithms and open source software framework written in Java for distributed storage and distributed processing of very large data sets, which is called big data in layman's language, on computer clusters built from commodity hardware. All the modules in Hadoop are designed with a fundamental assumption that hardware failures of individual machines or racks of machines are commonplace and thus should be automatically handled in software by the framework to store large data sets across distributed clusters. When we talk of cloud computing application, as all of you know, let's say you are an executive at a large corporation, your particular responsibilities include making sure that all of your employees have the right hardware and software they need to do their jobs. Then buying computers for everyone isn't enough. You also have to purchase software or software licenses to give employees the tools they require. Whenever you have a new hire, you have to buy more software or make sure your current software licenses allows another user. It's so stressful that can't be described in words. Soon there may be an alternative, and that alternative is here. For executives like you, instead of installing a suite of software for each computer, you would only have to load one application. The application would allow workers to log into a web-based service which hosts all the programs the user would need for his or her job. Remote machines owned by another company would run everything from email to word processing to complex data analysis programs. It's called cloud computing, and it could change, rather it's already changing the entire computer industry. In a cloud computing system, there is a significant workload shift. Local computers no longer have to do all the heavy lifting when it comes to running the applications. The network of computers that make up the cloud handles them instead. Hardware and software demands on the user's side decreases. The only thing the user's computer needs to be able to run is the cloud computing system's interface software, which can be as simple as a web browser, and the cloud network takes care of the rest. There is a good chance one has already used some form of cloud computing. If you have an email account with a web-based email service like Hotmail, Yahoo or Gmail, then you have had some experience with cloud computing. Instead of running an email program on your computer, in such a situation, you log in a web email account remotely. The software and storage for your account doesn't exist on your computer. It's on the service provider's computer cloud. Internet cloud services store your data on a server rather than on your hard drive, so you can access it from any internet-enabled device, are more powerful than ever before. Backing up photographs and important documents has never been easier. Google Docs and Gmail can take the place of Microsoft Word and Outlook Express. Banking sites take the place of expensive finance applications. All we have to do is be safe while we use them. Here, using cloud, the biggest concern of CIO of any company is what we call security measures. So for which a different branch of study is emerging very fast. In fact, it has already gained importance, what we call cyber security measures, and a lot of things are being done about that. Now we come to agile computing. Agile computing, when I use here or in the context of today's seminar, actually it is a word related to the method of software development. Agile is one of the big words of IT development industry. Put simply, agile development is a different way of managing IT development terms, teams and projects. The use of word agile in this context derives from the Agile Manifesto. This is important. A small group of people got together in 2001 to discuss their feelings that the traditional approach to managing software development projects was failing far too often, and there had to be a better way of doing things. They came up with the Agile Manifesto, which describes 4 important values that are relevant today as they were relevant then. It says, we value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, responding to changes over following a plan. Based on the usage and experience of Agile computing, following 10 key principles emerge. These are characteristics that are common to all Agile methods, and the things that I think make Agile fundamentally different to more traditional waterfall approach to software development. And these are: active user involvement is imperative, that's number 1. Next, the team must be empowered to make decisions. This is true anywhere. Requirements evolve, but time scale is fixed. It's not open-ended. Capture requirements at high level, lightweight and visual. Develop small incremental releases and iterate. Focus on frequent delivery of products. Complete each feature before moving on to the next. Apply 80-20 rule. Next, testing is integrated throughout the project life cycle. Test early, test often. And last, that is 10, a collaborative and cooperative approach between all stakeholders is essential in the Agile method of software development. Next topic that would be covered here is distributed parallel computing systems. As you all know, distributed systems are groups of networked computers which have the same goal for their work. The term concurrent computing, parallel computing and distributed computing have a lot of overlap, and often they are used interchangeably in the literature. The same system may be characterized both as parallel and distributed. The processes in a typical distributed system run concurrently in parallel. Parallel computing may be seen as a particular tightly coupled from the distributed computing, and distributed computing may be seen as loosely coupled from the parallel computing. Nevertheless, it's possible to roughly classify concurrent systems as parallel and distributed using the following criteria. 1. In parallel computing, all processors may have access to shared memory to exchange information between processors. Whereas in distributed computing, each processor has its own private memory, what we call distributed memory. Information is exchanged by passing messages between the processors. Next is sensors network, which also will be covered in detail. A wireless sensor network, WSN, sometimes also called as WSAN, that is wireless sensor and actor network of specially distributed autonomous sensors, is deployed to monitor physical or environmental conditions such as temperature, sound, pressure, etc., and to cooperatively pass their data through the network to main location. The more modern networks are bidirectional, also enabling control of sensor activity, that is exchange of information to and fro. The development of wireless sensor networks was motivated by military applications such as battlefield surveillance. Today, such networks are used in many industrial and consumer applications such as industrial process monitoring and control, machine health monitoring, and what is very common these days is machine-to-machine communication and so on. Mr. Goyal mentioned in his speech earlier in the day that cars were displayed which are communicating to each other. So, the companies are working on what we call connected societies. And recently held one of the largest events, most important event of telecom world every year is held in Barcelona, what is called MWC, Mobile World Congress. So this year's Mobile World Congress was held from 2nd of March to 5th of March for 4 days, and a very large segment of that, it was attended by 97,000 telecom professionals all over the world. So it's one of the largest, biggest events where all technology related latest developments are displayed. There, the theme of this year's MWC was Internet of Things. So the companies are working, and when you talk of Internet of Things, a whole large possibility of technological development exists, and where I think India can rightly strive to take its share of the cake. The WSN is built of nodes from a few to several hundred or even 1,000 nodes, where each node is connected to one or sometimes several sensors. Each such sensor network node has typically several parts: a radio transceiver with an internal antenna or connection to an external antenna, a microcontroller, an electronic circuit for interfacing with the sensors and an energy source, usually a battery or an embedded form of energy harvesting in remote applications. A sensor node might vary in size from that of a shoe box down to the size of a grain of a dust. Although functioning modes, as the nodes are called in WSN, although functioning modes of genuine microscopic dimensions have yet to be created. The cost of sensor nodes is simply variable, ranging from a few to hundreds of dollars, depending on the complexity of individual sensor nodes. Size and cost constraints on sensor nodes result in corresponding constraints on resources such as energy, memory, computational speed, and communication bandwidth that is required. The topology of WSNs can vary from simple star network to an advanced multi-hop wireless mesh network. The propagation techniques between the hops of network can be routing or flooding. That brings us to the last topic which will be covered today is next generation networks. And when we talk of next generation networks, we talk of wireless networks, sensor networks, and delay tolerant networks. The key components of NGN can be next generation are packet switched and use IP at the network layer. So that is the common feature of next generation network, is that they use all IP situation but IP component at the network layer. The center of network is the IP multimedia, IM is what we call IP multimedia service. This provides an independent platform through which access services such as 4G can use the network. The principal idea is to have seamless communication. People can be connected anywhere, anytime, anywhere and anytime. A key component of this is SIP, what we call Session Initiation Protocol. SIP acts as a signaling protocol. It differs from other protocols such as H.323 in that it was designed by the Internet Engineering Task Force, IETF, specifically for IP only. SIP is an enabling protocol that allows applications such as IPTV, Voice over Internet Protocol, VoIP, and messaging to be easily integrated. The implementation of LTE or WiMAX works towards adoption of NGNs. The reason for this is simple. LTE and WiMAX were built from the start to use an all IP core network. LTE does not have a native voice service, though several are proposed. The assumption for WiMAX and LTE is simple. Voice is also a data. So LTE and WiMAX inherently, they treat even voice also as a data traffic. But this gives rise to some issues. The main issue with while treating voice traffic as data traffic is being able to distinguish it from other traffic. This is where technology that differentiated service, what we in the short form we call DIFSERV or DS, can be used. Differentiated service is a protocol for specifying and controlling network traffic by class, stroke quality of service requirement, so that certain types of traffic get precedence, for example voice traffic, which requires a relatively uninterrupted flow of data, might get precedence over other kind of traffic. Differentiated services is most advanced method for managing traffic in terms of what is called class of service, COS. Unlike the earlier mechanism of 802.1p tagging and type of service, TOS, differentiated service avoids simple priority tagging and depends on more complex policy or rule statement to determine how to forward a given network packet. An analogy is made to travel services, in which a person can choose among different modes of travel: train, bus, airplane, degree of comfort, the number of stops on the route, standby status, the time of day or period of year for the trip, and so on and so forth. For a given set of packet travel rules, a packet is given one of 64 possible forwarding behaviors, commonly known as per hop behavior, PHB. A 6-bit field known as differentiated service code point, DSCP, in the Internet Protocol header specifies the per hop behavior for a given flow of packets. Differentiated services and the class of service provides a way to control traffic that is both more flexible and more scalable than partial protocol. So the idea is that in LTE and WiMAX, when voice is converted to data, but you see when you are doing internet browsing, you cannot afford packet losses, but you can afford some delay. That means some latency you can tolerate. But when you are using the same network for voice communication, you cannot. Neither you can afford packet loss, nor you can afford latency. So that is where this technology like DS comes very handy. I am very happy and I am very glad that such a topical subject has been chosen for national seminar today and by a leading institution called IPEM. I am sure the deliberations and the recommendations from this seminar will go a long way, not only benefit the students here, but also they will benefit the industry as such. And the recommendations will definitely be published in some way or other so that it reaches professionals. I wish all the very best for this successful conclusion of this seminar, and also I congratulate the organizers for choosing this topic and on this seminar, and also I thank the management for inviting me for delivering the